Hello everyone in a new lesson. Today we are going to study the relation between the cell potential E naught cell, the Gibbs free energy delta G naught, and the equilibrium constant K. Our objective for today is to identify the relation between the cell potential, the Gibbs free energy, and the equilibrium constant, and to specify the sign of each. We've seen that a positive standard cell potential E naught cell corresponds to a spontaneous oxidation reduction reaction. We know that the spontaneity of a reaction is determined by the sign of delta G naught. Therefore, the cell potential E naught cell and the Gibbs free energy delta G naught must be related. We also know that Gibbs free energy delta G naught for a reaction is related to the equilibrium constant K for this reaction. Since the cell potential E naught cell and the Gibbs free energy delta G naught are related, then E naught cell and K must also be related. For a spontaneous redox reaction, the one that will proceed in the forward direction when all reactants and the products are in their standard states, we can find that the Gibbs free energy is negative, which is less than 0. The cell potential E naught cell is positive, which is greater than 0, and the K, the equilibrium constant, will be greater than 1. For a non-spontaneous reaction, the one that will proceed in the reverse direction when all reactants and the products are in their state or standard state, the Gibbs free energy is positive, which is greater than 0. The cell potential E naught cell is negative, which is less than 0. And the K, the equilibrium constant, is less than 1. To identify the relation between E naught cell, G naught, and K, note that the fundamental quantity in the given relationships is the standard change in free energy for a chemical reaction delta G naught. From the quantity we can calculate both E naught cell and K. The relationships between three quantities is summarized with the following diagram. So delta G naught equals, on the left side, negative N F E naught cell, and below E naught cell equals 0.0592 volts over N times log K. And on the right side, delta G naught equals minus RT ln K, where delta G naught is the standard change in free energy for an electrochemical cell, E naught cell is the standard cell potential, K is the equilibrium constant for the balanced redox reaction at 25 Celsius, R is 8.314, which is the gas law constant, joule mole column -1, T is the temperature in Kelvin, N is the number of moles of electrons transferred in the redox reaction, and F is Faraday's constant, which is equal to 96,458 coulomb per mole. To practice on these relationships and apply them, let's solve one of the problems. The question says, what's the standard free energy change, delta G naught, and the equilibrium constant for the following reaction at 25 Celsius? 2Ag plus Fe forms 2Ag plus Fe2 plus. To solve this problem, we need to write the reaction involves an oxidation reduction reaction. Then we're gonna see that the oxidation half reaction at the anode, which is Fe, is oxidized to form Fe2 plus and 2 electrons, and the standard reduction electrode is negative 0.447 volts, and the reduction half reaction at the cathode, Ag plus 1 electron, forms Ag solid, and the standard reduction electrode potential is 0.7996 volts. To find out the first quantity, which is the standard cell potential for the cell, we're gonna apply the formula E naught cell equals E naught cathode minus E naught anode. And by substituting by the given values, we're gonna find that E naught cell equals positive 1.247 volts. Remember that the cell potential for the cathode is not multiplied by 2 when determining the standard cell potential E naught cell. With n is equal to 2, the equilibrium constant K is then E naught cell equals 0.0592 volts over n log K. So K is 10 to the power of n times E naught cell over 0.0592 volts. By substituting by E naught cell value, which is 1.247 volts, K is equal to 1.3 times 10 to the power of 42. To find out the delta G naught, we're gonna apply the formula delta G naught equals negative n F E naught cell. And by substituting by their values, we're gonna find that delta G naught equals negative 240.6 kilojoule per mole. That was the end of our session. Thank you for listening and see you in the next video.